Hi, my name is Keegan and I'm doing a question from chapter 7, which is circular and rotational motion. The question I chose to do was, on a snowy day when the coefficient between a car's tires and the road is 0.50, the maximum speed that the car can go around a curve is 20 miles per hour. What is the maximum speed at which the car can take the same curve on a sunny day when the coefficient of friction is equal to 1.0? So the first thing I did was write down the knowns and unknown values that I will be using in the situation. So I wrote down the coefficient of friction and the two different values. Our first scenario is going to be equal to 0.50, and then the second scenario, which is the sunny day one, is going to be 1.0. And this equation, we're also going to be using the acceleration for gravity, which is going to be 9.8 meters over second squared. We're also going to be using the maximum car speed. So on that snowy day, it's going to be 20 miles per hour. And one of the values we are solving for is that miles per hour on a sunny day. And then the last thing is radius, which we are also solving for. So to start this off, we're just going to write down the equation that we're going to be using. So this is the basic equation for figuring this type of situation out, but we are missing that radius value, so we are going to have to change the equation up a little bit. That way we can solve for the radius before we can start with the other process. Okay, so we're just going to equal radius to that max car speed squared divided by the coefficient of friction times gravity. I'm just going to plug those values in. Oh, also very important, you have to change the miles per hour to meters over second squared. That way we just kind of have equal units. I'm going to do over here. So we're going to have 20 miles per hour, and we're going to times that value by 0.044704. And that's going to get us to 8.9 meters over seconds. That's going to be our new, not new value, but our converted value for the max car speed, which is where we're going to plug in right here. It's going to be R equals that 8.9 meters over seconds, value squared, over that 0.50 and that 9.8 meters over second squared for gravity. Once we square this value, it's going to become 79.2. Then it's meters squared over second squared over 4.9 meters over second squared. And once this is converted, it's going to become 16.2 meters. So this is going to be our radius value, which we will use now to figure out what the maximum car speed was on that sunny day. So rearranging that same equation, we're going to be using this. Oh, actually both, but we're going to be using these equations. But we're going to end up with the maximum car speed equal to the square root of that coefficient of friction times gravity times that radius we just received. So we're just going to plug those numbers in. Perfect. And then after calculating the square root of these items, it's going to be 12.6 meters over seconds. But since this is in meters over seconds and it's asking for it in miles per hour, we're going to do a similar conversion like we did up here. Instead of multiplying it though, we're going to divide it because we're converting from meters to second back to miles per hour. Then after this division factor, we're going to be getting 28 miles per hour. So The maximum speed at which the car can take the same curve on a sunny day when the coefficient of friction is equal to 1.0 is going to be 28 miles per hour.